Okay, so let me go ahead and dive in now. And okay, there we go. So trying a new thing here, doing a little cameo inside the slides. I know you probably see me in a window as a participant and stuff, but I find that sometimes it's useful to have a little bit more context. Fortunately, I can't screen out my background. I'm in a room where the window, the during the wintertime, the sun's in the south and it just blasts right through. And so I've got hopefully some curtains, blackout curtains back there that will help the lighting. There's a glare. Sorry about that. We'll just have to deal with that. All right. So today we'll talk about the course overview, what we will cover in the course, and looking at the syllabus, of course, as always, and a little discussion about the online learning process. And then I like to talk a little bit about the expectations and how to be successful. And then, however much time we have, we'll give some introduction to modern communication systems. This is a little bit about the um, uh, technical issues, but I also like to mix in a little bit of career type information. So, with that, I'd like to introduce myself a little bit further. My name is Brent Horine, and as I mentioned earlier, I was a full-time professor at Manhattan College from about 2014. I started as a visiting professor, but transitioned to a tenure track professor and was doing that through about I think the end of 2017. Unfortunately, my father's health had degraded significantly during that last fall semester, and he had been full-time caretaker of my mom. So a little bit of personal details there, but I made the choice to resign, unfortunately, and move back to St. Louis to be a caretaker for my parents. And I worked in private industry while I was here, but it was a great opportunity to spend the last few years, last few months in my dad's case, and the last few years in my mom's case. And so, but overall in my career, I've spent most of it in startups, small ventures, and all. And most of those, well, probably half of those have been in communications. I've done lots of different things. I started off in microwave acoustics, working with piezoelectrics, and our technology was kind of dominant in the, let's say, um, 100 megahertz up to a couple of gigahertz in frequency for doing filtering of radio signals and TV signals and whatnot. And also in terms of resonators to generate signals in oscillators and that type of thing. So it was a kind of a niche industry, but as it turns out, it played a key role in not only defense applications and all during that era, but also in kind of empowering and enabling the digital cell phone revolution. So I like to say that I had something to do with the evolution of technology. It's a little bit obsolete these days. That kind of happens in engineering. What was high tech doesn't stay high tech, and other technologies come along. But that was a very hardware centric, very at the component level, very close to the physics of operation. So I did that for a number of years, and then as part of that, I wrote a lot of our software that simulated, modeled these devices, and then moved on to do a lot of different software work. But eventually I figured out that I kind of missed that communications engineering, and went back and then dealt with things at more of the Bluetooth area. I was involved with Bluetooth kind of from the get-go in the early days, and other similar type of technologies. I did a PhD, kind of a late life, midlife crisis PhD in cognitive radio, blending some of my software and AI skills that I had picked up along the way back into radio. So I've done a lot of waveform work, which is more the topic of this course. And then I did a whole bunch of consulting with 4G and 5G type waveforms, some specialty waveforms for um, uh, defense applications, space applications, that type of thing. Did some power amplifier circuit level work, system level work, and once I moved back to St. Louis, I did some work with um, using radio waves to detect the presence of people in a space. So we use smart devices to detect that there are bodies in a room, and actually could be able to count the number of people in a room using a lot of AI and signal processing on top of that. And then finally, I finished my career as director of advanced projects at Hypergiant, where we initially were doing some basically like synthetic aperture radar work from low Earth orbit on satellites, and imaging the ground, actually using GPS signals to do that. So it was a fun project. Moved on from that to do some work with the Army, still at Hypergiant, but doing research for the Army on applying some AI in their robotic combat vehicles. So I've got a lot of commercial experience, a lot of defense experience, a lot of space experience, and my experience ranges from high volume production. I used to build parts for the cable TV set-top converters and Motorola pagers back in the 80s and 90s, and those were in many hundreds of thousands and millions piece quantities. But I've also developed single piece bespoke custom things for space, and everything in between. So I like to share a lot of my professional experiences in class. So I hope that is useful to you. It's nothing to hold you that I hold you accountable for. It's just kind of help you kind of launch your career. You guys, for the most part, are second semester seniors. I expect you will be entering the workforce, or perhaps pursuing a graduate degree next year. And so I'm focused on kind of help you prepare for that. I've had what I consider a pretty successful career, and also hired and mentored a lot of engineers over the years. So I know what works and what doesn't work in particularly small to mid-sized companies, very high-tech type companies. And I know a little bit about what it takes to be successful as an engineer in those type environments. So I'll try to share a little bit of that knowledge, or whatever. Do with it whatever you want. So, but we will try to get some serious teaching and learning in on modern communication systems. So, so that's mostly me. I'm mostly retired now, still kind of helping out the department. So I enjoyed my time in Manhattan College, and I will, hopefully have a good semester with you all. And I will typically during the semester, I get to New York. I try to get there several times a year to visit my family and my friends, and just enjoy New York. But and when that happens, I will try to come in and deliver a lecture in person, and but I don't have anything scheduled at this point. So let's kind of dive in here. So the course here is this is your course catalog description: digital analog, wireless and wired communication systems, including satellite communications and personal mobile communication systems, techniques used in modern communication systems such as source coding, channel coding, multiplexing, multiple access, spread spectrum, cellular concepts, passband digital transmission, and basics of cognitive and software radio. And it's intended to be as a lecture lab. Actually, I'm not sure if this is the latest and greatest description. This one was from last year. I do have the latest on the formal syllabus. But all right, so we will have one lecture on analog, but we're going to spend most of our time on digital. That's where the world is. Not a lot of analog systems being designed anymore. There's a lot to be sustained, but I'm expecting that you're going to be working in the digital wireless arena for the most part. And yeah, so there's some expectation that we address wired communication systems also. Boy, there's just, with all these different things we're supposed to cover, we're not going to have time to talk about wired. But if you can understand wireless, it's going to easily translate to wired communications. Technically, wired, you're still working with waves, electromagnetic waves. They're just trapped to the conductor and on the surface of the conductor. But yeah, there's a few differences, but if we kind of understand wireless, you're going to do okay if you end up with a job doing wired type communications. And the logistics of doing a lab and a remote delivery class are challenging, but we'll work on that. So, all right, what are we going to cover? We're going to cover the concepts of communication, how information transfer is measured, and constraints and a performance to optimize. I've done a lot of research, but I'm an engineer at heart, and engineers, we are always faced with constraints in our engineering problems, and we're also looking to optimize some aspects of performance, right? So I'll bring these into our discussions as we go through there. So we'll review random variables, which I think most of you all have had some exposure to. And also we will talk a little bit about probability theory, which you've probably had some exposure to, but we're going to take it a little bit farther. These are essential topics to understand digital communications and communications in general. So we'll talk about some of these others. We'll spend a lot of time with modulation and optimum receivers, kind of from a theoretical standpoint, the way we design symbols, or the how we actually take information and put it onto our communication media. We'll get into and define all these things later. We'll talk about error control coding techniques, where we add a little bit of redundancy into our signals, so that if we do have an error in transmission or reception, we might be able to use some of that redundant information to recover the correct data. So yeah, so kind of newer this year is we'll take a little bit deeper look at machine learning in radio communications. That's probably just a last lecture or second to last lecture, but we're trying to include more of that. I actually do quite a bit of this work. It's one of my specialties, but it's just a struggle to cram everything into the semester, but you can look forward to that. A lot of radios are now defined in software instead of in hardware, and so we'll talk about some of those implications also. All right, so my expectations of you are to attend every class session, be on time, turn assignments in on time. Now, for those of you that were in my unmanned autonomous vehicles course last semester, there's a few of you. Hello again. There, I ran it differently. I let everyone work at their own pace. And the reason why I did that is for a number of reasons. It was kind of a self-driven type course, but in professional world, there are times when projects don't have hard due dates, or you're able to ask for extensions. Normally, things are planned out with due dates and all, but you can uh, flexibly work with your client, your customer, and update things in terms of due dates and whatnot, right? So that's normal. But there are a lot of other situations where no, that due date is firm. I was not directly involved in this, but a colleague of mine was, and they had won a research project for phase one. It was very successful at that. I think it was with the Air Force. I'm not sure. But then they were applying for their phase two award, which is actually a much bigger award. It's on the order of $1 million type of project over a couple of years. So enough to support a small team of people working on this. And but they were unable to get a signature from a person in the Air Force until very, very late, like moments. And they literally pressed the submit button 7 seconds late. 7 seconds. The proposal was not even opened and read. It was immediately rejected. It was probably a winning proposal. They had done some really outstanding work, but sometimes due dates are very, very important and rigid. So that's how we're going to do this. I want you to turn in your assignments, however far you've gotten. If you got stuck or for whatever reason, and all you have is maybe some comments and a sheet of paper, turn that in. If you haven't been able to complete it, give me some notes on what you would do if you had more time. Explain what you struggled with, what you couldn't figure out, and what you had tried. Just jot those notes down, and I'll try to give you as much credit as I can for those type of assignments. But we need the assignments turned in on time. So make sure you take note of that as we begin our assignments. I will occasionally grant a extension, but that extension needs to be granted a priority. So don't come along and just not turn something in and assume you can ask for forgiveness afterwards. So in the real world, we would need to formally ask our customer for an extension, and then hopefully they give it to us. But if they don't, we still got to do things on that schedule. So just trying to give you a little bit of flavor for the real world. Now, do your own work. Talk a little bit about this later, but I encourage people to work in groups, particularly for this remote learning type of thing. It's not fully remote. You guys will all be in a classroom eventually, but so work together, but do ultimately turn in your own work. Earn your grade, right? So grades aren't given out for free. Some people probably think I'm a hard grader. Some people probably think I'm a very easy grader. I don't know. I just try to grade fairly, and with what I know from my experience is an assessment of work well done that would be meaningful in the industry. So um, treat everyone with respect. Hopefully, don't need to say that, but I'll say it anyway, right? So, senior year, again, I think most of y'all are second semester seniors. Many of y'all will be graduating in May. That means you've got capstone going on. You've got probably some job interviews going on, or maybe you're applying to grad school. There's a lot going on. So, I'm hopefully this course will not be anything that overwhelms you, but it can deal with some very rigorous content. So do not fall behind. Right. So what you should expect from me to prepare you for a career that either uses communications, which these days is almost all EE careers, or actually develops communication systems. Right. So I want to help you understand the concepts, uh, and not just during lecture, but also during office hours. I host virtual office hours. Um, Part of what you pay in tuition is access to office hours. And studies have shown that students that take advantage of office hours and have a contact with their professor outside of lecture do much, much better, especially in their early careers. Your learning is going to be a lot better. I expect you to come to office hours, right? I will be flexible if you bring your issue to me and do not abuse it, right? I'm maybe ridiculously flexible sometimes, but I have some triggers in my life, and one of them is when I feel like I'm being taken advantage of. So if you start trying to abuse things and you're coming to me every week with some excuse, that's you're probably not going to be happy with the outcome of your course. So I will treat everyone with dignity, and I will empower you to get a great grade. I don't give out great grades for free, but I will empower you. I would love to give everyone an A in this course, and I would be happy to do that. But I've failed people before, so don't take anything for granted. Put in the work, please. Okay, how to be successful. I just mentioned office hours, study groups, study with intensity. As I kind of mentioned, some of this material is very, very rigorous. There's a lot of math going on in some of these. Sometimes it's a little hard to understand. What I mean by this intensity is sometimes you kind of have to bear down on a problem to be able to crack through to it. And that's when that learning happens. If you kind of, you know, get a little bit intellectually lazy. Hey, I'm guilty of that. I've done it. I have that tendency. But if you just kind of keep looking at the problem and hope the answer just jumps out at you, it's probably not going to help you learn. Right? Sometimes you really need to bear down and bring all that you know to the problem. You can go and find the answers to these in Stack Overflow or some maybe MATLAB forum or something like that. And as practicing engineers, we use those tools all the time, right? But there are times when we're working on a problem, and this is where you get your value from as an engineer, working on new problems, things that no one has done before, right? And we've got to figure those out. So read the material. You got to choose how rigorously you read the textbook. I teach mostly from the PowerPoints, and that's what I'm generally holding you accountable for, along with the assignments. But the textbook is there to help you. I've kind of swapped the required versus recommended textbooks around to kind of use a little bit one that's a little bit more accessible to you. A few more comments about that later. Yeah, in the ideal world, you're focused on learning rather than getting a grade. Yeah, I know you all want good grades, and I'm not naive. I know that there are still some employers and grad schools that are interested in your grades, but they open the door. You got to learn the material to be successful, right? Whether that's successful in an interview or successful once you actually take that job. Um, so part of that is, this whole studying with intensity of that type of thing is make an effort to understand, but do not wait too long to ask for help. There's a balance there. We'll help figure it out, right? But don't wait until the end of the semester to say, "Oh, I didn't understand, this material or whatever." So come get help before that, right? So how you will be assessed, right? So exams, three total. So I've been kind of playing with this, but this is what I've settled on. I think it's going to work out well. So we'll have a midterm and final, and those will be typical. We'll also have an exam earlier on, and before the midterm, it'll probably be more of a quiz. I'm this semester. I'm relying much more on the assignments uh, to help reinforce your learning. Right? If you just, we know if you just come and listen to me blabber through lectures every, week, twice a week, um, and don't go beyond that, you're not going to take a whole lot away from the course, right? So sometimes that reinforcement occurs in studying for tests, right? And we will do that, but hopefully most of that reinforcement is going to be found when you perform your assignments. The assignments will mostly be MATLAB. Probably, last year I did a lot of kind of traditional problems out of the textbook and other problems I came up with. I'm going to try a new thing this year and do most of our assignments, if not all of them, as MATLAB programming assignments, with the intention that by the end of the semester, you're going to walk away with a little radio simulation, and we're going to build upon that each week. Most weeks, and not when you have exams and stuff, but most of the other weeks, you will do a MATLAB assignment, and hopefully each one will be a small increment. But by the end, you'll be doing quite well with it. In the ideal world, we would use MATLAB to analyze and model our systems and actually implement them in GNU Radio. GNU Radio is a software-defined radio. I still may try to introduce you to GNU Radio, but I'm just a little concerned that all the logistics of getting it installed on personal computers or school computers is a little bit difficult. But if we, I'm still looking at that, and if you are particularly interested in pursuing communications, wireless communications as a career, and you want to dive a little bit deeper, then you may choose to do some of your work in GNU Radio instead of MATLAB. So anyway, that's subject to discussion further on. And there will be a self-evaluation. So that's a new thing I started last semester, and I like it. It is essentially at the end of the semester, the last week, you will fill out a Google Online form that's basically going to walk you through evaluating your learning. And you will, I'll talk a little bit about this as the semester goes on, but you will kind of describe what worked well, what didn't work well for you, and evaluate yourself to me, and then you'll give yourself a grade. If I feel like you were honest and meaningful in that self evaluation and your discussion of that, you will get those points for your grade. And that'll be 20% of your grade. So it's even if you felt like you did not do well, um, but you can explain what you did learn and that type of thing, and that maybe you botched it at the beginning of the semester, but you figured things out at the end of the semester, then great. Give yourself the grade you think. If everyone writes down 20 out of 20 on this, and everyone is appropriately supporting that grade, then great. That's 20 points you get. So, all right, let's switch to our syllabus and look at that. Where is that? Why don't I have that? Okay. There it is. Let's just. Okay. All right. So here's our formal syllabus. I've already covered a lot of this, but there's your textbook. Okay. First of all, here's my emails. Best. This is a classroom, I think, to be assigned, and a little footnote. The course will be delivered remotely for most sessions, but your attendance in a physical classroom is still expected, right? And I think those classrooms, I'm on Central Time, so catch me if I make some time mistake. Sometimes I'm off by an hour. But hopefully I do all the calculations correctly. So I will hold office hours on Tuesday, but also available by appointment. Here's a textbook. Should be in the bookstore. Again, I'm not on campus, so I can't go and actually physically verify that. If you prefer the ebook version, the publisher has a discount code, and so you can go there, look this textbook up, make sure you use that student code, and you'll get a good deal. This second textbook is kind of the gold standard, but it's really more oriented towards a graduate level textbook. And if you are pursuing a graduate degree, whether master's or ultimately PhD, or a career in digital communications, this book will serve you well. It is a bit more rigorous than the Lothian and Ding textbook. This is, if you can see me, oh my, this is the textbook. The screen background is messing with it. But anyway, all right. So we already talked about the web catalog description. Hopefully y'all have had 303. I think that Signals and Systems, the first course. In the ideal world, you've also had the random variable statistics and probability course, and also the second semester of Signals and Systems. Hopefully you've had those or taken those concurrently. The only prerequisite is 303, but if you've had those other courses, you're going to do, you're going to be better prepared for the course. If you have not or are not currently in the statistics and probability course, it's like 320 something or other, I can't remember. Or the second semester of Signals and Systems, then you may want to let me know. Again, shoot me an email or something. Show up to my office hours, and I'll try to help you. Help make sure that you have the information background, because we do use a lot of the concepts from those other courses. All right, so there's some specific goals here. How are we doing on time? These are your typical learning goals, learning objectives. They're kind of in order, kind of not, but so these first few are kind of conceptual, and then we get into some others. Some of these um, we could spend the whole semester on, right? So one lecture is not going to necessarily, let's say, fully satisfy learning objective three, but it will address it, right? And then another lecture will add on to it, and another lecture will add on to it. So by the end of the course, you should be able to talk credibly about all these different issues. So you can look at some of the topics covered here. Um, and these are kind of generally from the course description, so we don't have to go over those again. I'm sure the thing y'all are interested in is our grading policy here. So let's see if I've got this correct, I hope. So we'll have lab projects and assignments. Again, these are mostly going to be MATLAB. And when I say MATLAB, it may also include Simulink. Um, there'll be a self-evaluation worth 20%. There'll be a test slash quiz worth 10%, a midterm 15%, and a final 25%. Hopefully that adds up to 100%. I think my scale is fairly conventional. Let's try to stay up here at the top and not be down below. So, all right. So, how can you be successful in this course? Well, all these class notes and homework solutions, I'll be posting those on Moodle, trying to give you feedback on your assignments and that type of thing. Make sure you visit the course webpage regularly to look for new updates. So, you guys are responsible. You're seniors, right? So you know this. I don't need to treat you like freshmen. So anyway, um, you guys are the ones responsible for fulfilling your course requirements and completing all classroom assignments. Um, and turn in assignments on time, take advantage of office hours, form a study group early in the semester. Studying with classmates is a collegiate tradition and can make the experience more effective and more enjoyable. I strongly encourage this. However, your assigned work must be your own. By the time you turn it in, your work needs to be your own. If you have any questions about where to draw the line between study groups and individual work, talk to me. Okay, so um, every year I've got some students that work together and they work together wrong, and they all turn in the same wrong solutions. So don't be that person. Yeah, work together. Um, Work with me. I want your assignments to, they're really not beneficial if when you turn them in, they're all wrong, right? You might learn a little bit, but I want you to get to the correct results when you're turning them in. So, um, all right. So the rest of the stuff is boilerplate. Does not mean it's not important, but you've probably all seen it before. Classroom attendance is expected and required. There's additional assistance available. Students with disabilities should, be already in contact with the SRC, and every year I work with them, so no worries about that. Academic integrity and other expectations. So these are all important, but I expect you to review those on your own. So, all right, let's say that is done. Why am I not? Uh, there we go. So let's. Okay. Now let's see what's next. I think I'll talk about the course schedule. So let me get back here. Share this. Okay, so this schedule is always subject to change. It will be represented in Moodle also, but this document is up there in Moodle. I've got some reading assignments already put in, but as we kind of get down towards the end, maybe less so. So I'll still need to work on those. Um, I'm not going to ask you to read every chapter. We're going to kind of follow some different orders than what the textbook does. Um, but yeah, so this gives you some expectations. Our first exam will be on Tuesday, the 6th, February 6th. Here's another thing to note. We'll have a spring career fair. I know that some of you all may want to duck out of class early or whatever, so please give me the courtesy to let you know your plans. I understand interviewing, networking, super important at this phase of your career. So want to give you the opportunity, but we will have lecture nonetheless. Spring break, Good Friday, part of Easter holiday, and we have a wellness day. So all those days are no lecture days. There's midterm on March 5th, and that's just well, I guess it's a reasonable amount of time after that first exam, and also you can look through here and figure out the topics we'll be covering, and you can also look at the Moodle page. So let me now share the Moodle page. My uh, view might be a little bit different from a student view. I'm not sure. I don't. Uh, Maybe there is a way for me to look at the student view, but I don't know. So here's my email address. Here's my phone number. Remember, I'm in a central time zone. I tend to be an early riser, but be courteous with using that. This is my cell phone. I don't have a Manhattan College phone number anymore, so use this. Feel free to text me. I get so many spam calls. I don't often answer the phone from numbers I don't recognize. So it's maybe sometimes useful to text me first and say, "Hey, can I call you?" But whatever, it's there, and use it when you need to. So the syllabus is posted up here on Moodle. There's a little section on getting started, and it's just some of the stuff I've already talked about. One thing I will note, well, actually, I'll just cover that as we get to it. So there's textbook information is repeated here, right from the syllabus. There's a link to our virtual classroom right there. So if for some reason you cannot attend class, let me know. Shoot me an email saying, "Hey, professor, car broke down, or the weather's bad, or my gerbil died, or whatever, and I can't get to class today." So use that to experience class from wherever you're at. Office hours, you may click on this, and during my Tuesday morning office hours, right? And that's how you will join up, and we will do them that way. You may also, if you're unable to attend my normal office hours, I did kind of look at the other courses that most seniors would be registered in, and try to make sure there wasn't a conflict. But maybe you've got a conflict and you can never make my normal office hours. Then um, go here, click on here, find a time, and make an appointment. I will say that uh, the system is set to give me at least 4 hours of notice. So you're not going to be able to make a appointment for right before uh, the you want to meet with me, right? So I might be out hiking, I might be out sailing, or just working on the yard, or who knows what, right? So as again, I'm retired, so I'm trying to enjoy my life. So I may not be at a point where I can be reached. So I am part time. I'm not full time, but I do love working with students, so I want to make myself available. So I'm generally going to be available on Mondays, Wednesdays, and Thursdays. Now, what you're seeing right now is in Central time zone, but when you click on it, it should appear in your time zone, I'm guessing, but just watch out for that. All right, and we've already gone over the course schedule. There's also a YouTube playlist. You know what? Let me go back to and let me just share my entire screen here. That'd be easier. So I have a YouTube playlist that you can access, and these are all for this course. All these that are up there right now were from last year. Last year was a little chaotic because literally, I found out that they wanted me to teach the Friday before the semester started, and we didn't even get approval until Thursday, I think. So after the semester had already started, so that was a chaotic semester. I was developing a course on a week by week basis, so some of these lectures might be a little rough. But they're up there. As the semester goes on, I will gradually replace these lectures with the new ones, right? So, all right, what else? So for some of these, I'm trying to put down some estimated times to complete. So here's some kind of boilerplate stuff that the college has on these Moodle templates. So I'm not exactly sure how accurate some of these things are, like these readings. Here's to read these. These aren't graded. Just try to read them and mark them that you completed it. I'm not really looking at any of that information, but it's just is what it is. So if you click through on this, you might get a little bit more detail. Here's a summary of what we expect to accomplish in the week. There's 2 lectures in this week, and then there'll be the readings, and there'll be this estimated time to complete. Not sure how accurate those are yet, but I'll try to improve those as we go. And then there'll be a homework assignment, right? So this will give you a little bit of idea on what's going on. Then you should see my both PowerPoint and PDF versions of our lectures. And so I've uploaded some of these. I'll probably by the end of the week, I'll have all of them uploaded. But I will typically polish them right before class session. So feel free to look at these. I encourage you to look at these things before class. But afterwards or whenever, make sure you get a fresh one downloaded. Our assignments are going to be Well, let's see. What does this show here? So here's the assignment. Let's see if we can get. Can we get up? So when you click on this, you should see actually a different view of it. And um, but here's the example of the assignment. Um, don't start working on this yet because I might change it. But we'll use MATLAB, create a cosine signal at 100 megahertz with amplitude of 10 volts and duration of 1 microsecond, plot the time domain, save it, and send it to me. The rest of this is just kind of teaching you how to use Git um, to archive your source code. But as an example, this code will do essentially the first and second assignment. I'm using Octave on my Mac here because my personal license version of um, MATLAB is too old to run on my new MacBook Pro 3, whatever. But Octave does the same thing. And we'll talk about getting access to MATLAB and or Octave, whatever you prefer. So this is the first assignment. That's the second assignment. So again, that's you know, this is the type of organization that I expect. I expect good programming, and we'll get there, right? So I'll teach you how to do things well, also. So giving you some information there. So that's pretty much the uh, Moodle type things. There's more to look at there, but nothing I don't think that's particularly surprising. And so let's real quickly get back to our presentation and wrap things up. For the most part, this class is an hour and 15 minutes long. I feel like we don't need a break, but there may be times where we do kind of a stand-up break where we just kind of, stand up and shake things off for a minute and sit back down. But I think we'll be better off if we just plunge through. All right, so aspects of wireless communication systems design for future engineers. So here's a little bit about the different ways you might work in this industry. You might work with circuits and components. It might be very hardware centric. You might be working with a RF mixer or an antenna. A lot of kind of the recent technology is focused on really advancing antenna technology, in particular doing many element beamforming. So are antennas directional? Do they require tracking? If you're trying to communicate with the satellite that's in low Earth orbit, it's going to rise above the horizon and go above you and then set below the horizon, all within about 10 minutes, right? So you've got to pick that satellite up with your antenna and track it as it goes across. So it's non-trivial to do. MIMO is multiple input, multiple output. So basically, instead of just having one transmit antenna and one receive antenna, we have multiple ones of these. So you'll see these on cell phone towers, and you'll see them on your Wi-Fi router also, where there's multiple antennas. In your cell phone, there's actually sometimes multiple antennas in there also. They're just on the PC board inside. Filters. This is where I spent a lot of my career in developing, mostly for receive filters. Okay, so here's our first little bit of terminology. TX is shorthand for transmit, and RX is shorthand for receive. So on the transmit side, we might be required to make sure we don't have any emissions outside of our allocated band of frequencies that the FCC or Ofcom or whoever, a regulatory agency, says that we can transmit in this area but nowhere else, right? So we may need filters to help with that. On the receive side, we want to select out only the signal we're interested in and get rid of all the others. That requires some filtering. And sometimes we need to get rid of strong, really strong interfering signals that would otherwise create what we call intermodulation distortion. Um, and amplifiers in recent years, there's been a big push for highly efficient but still linear. There's a strong trade-off between these two, and wide bandwidth. These are all in conflict with each other, all these three different things. They're all very desirable, but you can't achieve all of those independently optimally, right? So on the receive side, we want low noise amplifiers with a high intercept point. In other words, minimum intermodulation distortion are very linear, right? And these are in conflict with each other. So when things are in conflict with each other, this is where you get paid big bucks to solve those things, right? So at more in circuits and components, local oscillators, these are things that generate signals. These tend to need to be low phase noise and also tunable in a lot of conditions. And those are somewhat in conflict with each other. These days, more and more of our radio is digitized, and then the processing is done in an FPGA and firmware, or in, let's say, a CPU or even a GPU in software, right? And so in our cellular systems and 5G and 6G, all the trend is to do more of actual waveform processing at a data center in a bunch of GPUs. NVIDIA has a whole product line dedicated. They're not super common and successful with that product line yet, but there's a lot of that. So we'll talk about that towards the end of the course. But there's a lot of FPGA stuff done. These are digital down conversion, basically decimating filters where we take high sample rates and wide bandwidths and we channelize those down to low sample rates, narrow bandwidths, and vice versa. When we're transmitting, we need to kind of go from low sample rates to high sample rates, low bandwidth to wide bandwidth. There's algorithms to be implemented in FPGAs for digital pre-distortion. Basically, amplifiers are most efficient when they're nonlinear. Oops. But we need them to be linear. So we linearize them using basically, we kind of pre-distort the signal to compensate in an opposite manner of what the nonlinear distortion will produce. Then we may also want to reduce some of the peaks in the signal, because that makes it, if a signal has some really high peaks in it in terms of amplitude, that makes it really hard to amplify. So we might try to figure out how to reduce the distortion or reduce those peaks without introducing too much distortion, right? So these are all hot topic research areas. And then there's the CPRI, the Common Public Radio Interface. That's a fiber optic interface that might go from the base of a tower up to the top of the tower, where you have more of what we call remote radio heads or systems up there. At the systems level, we I think we're all familiar with cell phone networks and how they have multiple different towers. So there's a whole aspect of cell planning, deciding where to put those towers, how to point the antennas, whether to tilt them down or tilt them up, depending upon the area coverage and the capacity that you're planning for. A lot of that's been built out. We're always building more, though. But the hot topic thing here is these low Earth orbit satellite systems and the constellation planning of those, including the ground station support and the mesh networking that it requires to go from one satellite to another, that finally has view of the ground station antenna to download the information or upload the information. There's mobility aspects, handing off your connection from one tower to another as you, let's say, drive down the highway. Paging is the problem or the solution of if you're not at home, you're somewhere else. the cell phone system still needs to figure out how to call you, right? So what tower uh, do they send basically the ring to call you, right? Someone's calling you. Um, how do they find that radio? So there's a whole process where as you connect to different towers, you kind of do a little bit of registration, saying here I am, and paging is the process of routing the uh, signal to that particular tower to your particular phone to actually ring it. It's actually more complicated than one might think. In the old days, all our phones were hardware connected uh, via a hard line to a particular relay or switch in a switching system, and it was always there, right? Once you have mobility, all that changes. There's billing, authentication, authorization. You've got to track all these things. There's licensing. All these things can come into play, and engineering problems to solve. Uh, there's, now we talked a little bit about algorithms. Maybe some of these digital predistortion, crest factor reduction are algorithms, but these all need to be implemented in software and firmware, or FPGAs. Receiver equalization is a big hot topic. That's really more of a graduate level topic, and unfortunately, we don't really have time to get to that. But that's when you're working on receivers, that's a big area of efficiently equalizing or compensating at the receiver for all the crazy things that happen in the channel or while that signal is moving from the transmitter to the receiver. There's concepts called multi-user detection, media access control, scheduling. We might talk about this multi-user detection in our CDMA spread spectrum lectures in the last few weeks of the course. But waveforms, most of our class will focus on this. So these are the design and analysis to optimize within constraints and for a given channel type, the spectral efficiency and how much data can we get over our bandwidth, and capacity and rate, the coverage, how far we can go with the signals, handling errors. A lot of this technology and error handling was developed by NASA when they needed to send space probes like the original Voyagers and such whatnot to distant parts of our solar system, and needing to get the data back from them from a very power constrained system. So resilience to multipath interference. So all these things, don't worry, I'm throwing out a lot of jargon here, but we'll talk about all of these. So we're going to run out of time here in a few minutes, but we'll get started on this, and then we'll circle back and cover it Friday. But here's where we start to get into our real technical matter. But I want to motivate that. What are we concerned about when it comes to communication systems? Well, our goal is to move data from where it's relatively known source to where it's relatively unknown. Okay. And we measure how well that information is known by this term entropy. Now, you may have studied entropy in physics or thermodynamics course or something like that. I don't think electrical engineers study thermodynamics as much as we used to, but it's just not time in the curriculum. But you probably saw entropy in physics or maybe even chemistry at one point. We use that term in communication systems in a bit of an analogous way. It means a little bit different, but it's really the measure of surprise in the data. Basically, if there is no surprise, then it's already fully known and there's no need to send it, right? So if that's kind of what I'm trying to address here with this relatively known versus relatively unknown. If the the data is, or the information or data is certain. Like the Earth is somewhat spherical, right? Um, Maybe you're a flat earther, hopefully not. But there's not a lot of surprise in that statement. So there's really not a need to communicate it anywhere. We already know it, right? So, but what is the weather today in Tokyo? I don't know. So that would need to be communicated to me, right? So there's a mathematical expression of this, and we'll talk about that a little bit more as we go. So I'll skip over that for now. We will return to that. So uh, fundamentally, we're moving data from a data source across a channel to the receiver. Now, this channel might be uh, free space between two antennas. It might be some wires, cables, might be fiber optics. Um, Many times we include things like the antenna characteristics, the power amplifier, and some of those other components, the low noise amplifier and the receiver, as part of that channel, right? So, and these channels have various degrees of non ideality, right? So the problem is none of these elements are ideal, especially the channel, right? So these are going to cause some problems in it. The job of the receiver here is to correctly estimate what was originally sent by the data source over this channel, right? And if everything was ideal, that would be easy, but there's all sorts of problems, right? So we're faced with many constraints and challenges. So the questions we'll be discussing are, how do we deliver an optimal solution? What do we mean by optimal? Maybe it changes from case to case, right? So we'll think, well, we're almost done. So you can kind of think to yourself. We don't have time to kind of open it up to discussions, but think, and maybe we'll talk a little bit about this uh, on Friday, or maybe I'll do an online poll in the meantime. But what do you think we are constrained by, or what do you want to optimize? And then finally, this equation is kind of fundamental to the whole course, right? Capacity theorem, and it relates how many bits per second we can communicate error free, given the bandwidth that we have and the signal power ratioed with the noise power. So this represents an upper bound. We can't get any better than this to do it error free, but it's a great challenge to get there. This tells us what the best is, the optimal, but it doesn't tell us how to get there, right? So that's what you get paid for as a communication engineer. If you figure out a way to get better signal power or lower noise power or more bandwidth, or to use all this more efficiently, let's say by using some new error control coding technology or something like that, then you get lots of money. So that's what we get paid for. So all right, so hopefully that gives you a good idea on what's going on. We'll dive in more on Friday and talk a little bit more about the theory and all that we do. And let's see if anything else. So yeah, I got just a couple of minutes. So basically, there are some terminologies in engineering that maybe were somewhat unfortunately chosen. And so there are some controversial topics that may evoke trauma in some people. Engineering is often adopted terminology without regard to how they may be perceived by some people. We're trying to move away from those terms into more modern but still descriptive terms, but you likely encounter some of these terms in practice, and I believe it's important for you to understand these. You know, an example of this is a master-slave type of relationship, right? That's an unfortunate choice, and we're trying to move away from that as maybe you know, agents and that type of thing, but there's, you know, difficulties in that, and you will still see some of that terminology. So another one that doesn't have such nefarious origins, but still has maybe some connotations, is when we talk about noise. We'll often talk about noise as being white noise or non-white or colored noise. And this is simply an analogy to the visible light spectrum, but it could have some you know, connotations to someone. So we'll try to use these terminologies in a respectful way when it makes sense, and we'll try to avoid them when it makes sense also. Another issue is, which may make some uncomfortable, is discussing defense-related applications. I'm just going to read what I wrote up here on this. I think we can agree that war is terrible, but many sovereign entities have chosen to develop and maintain defense against other aggressors. This includes nations, of course, but also may include various law enforcement and similar type entities. Many of you will find employment in the U.S. defense industry, and this course should help you prepare for that career. Examples may be taken from current wars and conflicts. Nothing I say should be taken as supporting one side or another, or favoring or disfavoring the choice of the parties to take up arms. I may have my own opinions, I certainly do, but they are not relevant to this course. So, but the issue of using communications and defense applications is important, as it is in commercial and consumer type applications also. All right, so hope that makes sense. Thank you for sticking with me here to the end, and we will see you Friday.
Thank you, Professor. See you Friday.
Have a nice day, Professor. Thank you.
Thank you, Professor. Friday.
Take care.
Thank you.